Welcome to our field trip to Island Park. Also, I call it often O'Leary's, and it's a place on the bay where we can see a number of issues about climate change. We can see mangroves. We can see a living shoreline that was planted by the Sarasota Bay Estuary Program. And we can see a living seawall right in front of O'Leary's. And these all relate to sea and bay level rise and adaptation for things like hurricanes and adjusting to storm surge and these kinds of issues that we are dealing with more and more as climate continues to change. So this is an example of a living shoreline, and it's made up of red mangroves and black mangroves, and living shorelines help to protect our shores and our property and even seawalls, as we'll look at here in a moment. So what the red mangroves do is put down prop roots like this and grow into the substrate and create this really dense thicket made up of the trunks of the trees, the aerial roots, and then the black mangroves out there also put up nematophores, little pencil-like things that are roots where the black mangrove is trying to get more oxygen. One of the other interesting things about red mangroves is that it does what's called viviparous reproduction, and so these little pencil-like things right here are a sprouted new tree growing still right on the mangrove, and what happens, they grow bigger like this and will eventually drop off the tree and float in the water. And on this you can see a root coming out here and a set of leaves, or a new leaf coming out right there. So they'll float in the water until they get stuck into some mud or some good substrate to allow them to take hold and begin a new mangrove forest. So another interesting thing right here is that mangroves and other living shorelines have been adjusting to changes in sea level for thousands of years. And what happens is, as the bay level comes up, sea level comes up, the mangroves will move further shoreward so that they don't drown. And these aerial roots right here, down here, are growing landward and growing into and rooting into the substrate, just as they would do if there wasn't a seawall there, and beginning to move more shoreward and adjust to rising sea levels. And so this dense thicket that is created by the mangroves does a number of functions for our ecosystem. It protects the shoreline. It provides habitat for juvenile fisheries and crustaceans and organisms and algae and whatnot will grow on the stems of the mangroves and provide additional food source for those juvenile fisheries. So very important. And the mangroves themselves, as they grow, are sequestering nutrients. They're taking up nutrients from the water and from the sediment there and sequestering it in their bodies. And as leaves drop and other organic materials begin to decompose, it becomes soil organic matter, which is the two parts of sequestration of carbon. One is the above ground portion, and the other part is the below ground portion that occurs, and there's actually more carbon sequestered in the organic soils than in the biomass of the trees themselves. And marine plants like mangroves are often referred to as blue carbon, and they are more effective at sequestering carbon than typical terrestrial plants are. And so now we have this massive thicket of roots and stems and whatnot that are helping as we get storm waves and storm surge coming from hurricanes and other storms. That massive thicket breaks the wave energy and prevents it from reflecting off of the seawall, in which case the wave energy goes straight up or straight down and will either overtop the seawall and perhaps erode behind it, or will erode underneath it for that portion that is reflected downward. So these mangroves that are growing in front of a concrete seawall, while you might tend to think that a concrete seawall will be preferable to protecting your property than are mangroves, the mangroves are actually protecting your seawall. And in some storm events that were monitored up towards the Chesapeake Bay, there was a mangrove shoreline and a concrete seawall side by side, and the concrete seawall failed and the mangroves were unaffected by the storms. They have been doing this for thousands of years, and if we allow them, they'll continue to do that for us, doing free ecosystem services. And rather than acknowledging that historically, we have tried to remove mangroves from our shoreline, and in fact, we've been very successful at that. We have removed up to 80% of our mangrove shoreline and replaced it with concrete seawalls. And so we've lost that nutrient uptake capacity. We have lost the capacity to sequester carbon. We have lost a good deal of the fisheries habitat that are provided by mangroves. And so here at O'Leary's, they put in what we are referring to as a living seawall. The living seawall was constructed in sections off-site. A crane was brought in, and each section was numbered and set in place in front of the seawall. The seawall, the living seawall, is a sloping structure that helps to dissipate wave energy as it runs up that slope, and so it's actually helping to protect the seawall. And the hollows in the living seawall are providing habitat for fish and oysters and so on to grow on. And here you can see that the oysters have colonized on the structure of the seawall. And we are seeing more and more fish adjacent to the seawall, and moat has, this is an inset here showing a large redfish feeding along the edge of that seawall near those oysters. And this is a rock field out in front of the seawall, which provides some roughness and helps to break the wave energy prior to hitting the seawall. So all of that structure is actually protecting the seawall behind it. This is a good example of why mangroves have some advantages over vertical seawalls. What happens with a vertical seawall is when waves come in, the wave energy is reflected. Part of it goes straight up, and part of it goes straight down. The part of the wave energy that goes down often erodes the toe of the seawall, and eventually the seawall will collapse, usually seaward. And that's exactly what happened here. We had a recent storm. Waves overtopped the seawall, when they hit this huge piece of rock, what happened was exactly the same process. Part of the wave energy was reflected downward, eroding the base under this huge rock that I'm sitting on, which has caused it to fall seaward. And it's exactly the same process that often happens with seawalls. And mangroves, on the other hand, attenuate that wave energy. They dissipate it over a large area, and if they're in front of your seawall, they will actually protect the seawall from that wave energy. We saw previously how storm waves had eroded under these large rocks and they fell waterward. And one of the interesting things that has happened is it's exposed all of these fibrous roots from the palm trees that are planted here along the shoreline. Living shorelines often help to hold the shore together and reduce erosion because of these kinds of fibrous root systems that grasses and palms have. They help to hold the soil together. So this is a great opportunity to actually see some of the roots that we wouldn't ordinarily be able to see from these palm trees. So this is a living shoreline project that was planted by the Sarasota Bay Estuary Program, and it was jointly funded by City of Sarasota and the Southwest Florida Water Management District. And the purpose of it is to demonstrate how living plants, a living shoreline, can prevent erosion. And we've had a number of storms over the last year that have had a fairly severe impact on some parts of our shoreline, but this has held and hasn't eroded. The plants get beat up. This is a good example of things like the grasses, the spartina, will get beat up, but will be coming back as they are now. Like crop support greening up there. So they've done their job. They've protected the shoreline. Their root system is very fibrous and helps to hold the soil together and prevent erosion, just like sea oats do. Interesting example right here. Had some sea oats here. We're getting it on camera. And their extensive fibrous root system holds the beach dunes together as well. These are live new trees. They have demonstrated that rather well in this instance, protecting the shoreline. We'll see some examples probably as we walk down the seawall. This is larger. We post the Hess phone numbers on it and allows people to be able to dial that phone number and get a scientist discussing the purpose and function of this living shoreline project. So it's supported by the Science and Environment Council of Sarasota and Manatee Counties. Mangroves provide a number of different functions, including shore protection and habitat for fisheries, bird nesting sites, and sites for oysters and barnacles, etc. So they, through this process, provide nutrient uptake from the water and from the substrate and sequester carbon from the atmosphere. And they're part of what's typically called blue carbon, which is 3 to 5 times more effective than upland tree sequestration processes. And lastly, they're a self-propagating system where they germinate on the tree, fall into the water, float away, and begin a mangrove forest somewhere else.